Greetings, this is Ben, and in this video I'm going to show you how to use mice to replace missing data. Now, this is the third video I'm making about missing data. In the second video I showed you how to do median imputation, or replacing missing values with the median from the variable. And I showed you how to replace missing values with the number 0 in case it's like a dummy code situation where everybody who wasn't in an experimental condition in this instance needed to have a 0 instead of an NA. In this one I'm going to show you how to replace values where you might have a variable that most people answered, but a couple of people didn't answer, or one person didn't answer. And in the data set that I'm looking at, there are a handful of variables where maybe somebody's eyes just skipped a line, and so for whatever reason they don't have a score on one of the variables. And instead of just deleting people like that, we're actually going to guess, based on their answers to all the other questions, what they would have answered if they didn't skip that question. Now, in order to do that, I should say there's an assumption that the reason, or that the missing pattern, is completely at random, meaning there's no systematic bias in who has missing scores. Because if, for example, the people that refused to reply to a question did so because they didn't want to, because of social undesirability of the question, or maybe because they thought the question was like a liberal bias and they're conservative, and so they thought, I'm not answering that, then it may actually not be a random missing pattern. There's a systematic effect to the missing pattern, and it may be inappropriate to try to guess what they would have replied. And so you can do some tests to see if there are, if it's a biased missing pattern or not, but that's not what this video is. This video is just showing you how to use mice to guess what they would have replied. So the first thing you want to do is make sure that you install the mice package. So install.packages, left paren, quote marks, mice, close quote, close paren, and then load the mice package. So library, left paren, quote mark, mice, close quote, close paren. But I've already installed and loaded it. And we're using this deb2 data set, which is actually a debate data set that I've been working with, but I had to actually deal with some other missing data problems, the most important of which was the control, mixed, repcon, and demcon had missing scores for everybody that wasn't in one of those 4 conditions. And so obviously most of the values in each were missing because 2/3 of the, or 3/4 of the people were in one of the other conditions. And we don't want to try to guess what condition they would have been in. We know what condition they were in. It's just a feature of the way the data was coded that if you weren't in that condition, you had an NA. And you need to do you need to make sure that you don't have anything like that before you use mice. Otherwise, mice is going to be trying to guess a value for the 75% of the people that weren't in the control condition. And then it's going to try to guess a value for the 75% of the people that weren't in the mixed treatment, and so on for the Republican treatment and the Democratic treatment. And so you don't want mice to be doing that. The other thing is, we needed to deal with age first, because we didn't want to try to be guessing people's age. We don't really have variables in here that should be highly correlated with age. We really don't have anything to go on in trying to guess people's age. And so we just did a median replacement with age. So now there's no missing values in age, and there are no missing values in the experimental conditions. We just have a couple of missing values sprinkled throughout some of the variables that we're trying to measure. Now, one thing I also want to point out is we have this count NA variable, and that actually doesn't tell us anything useful at this point. It just tells us how many missing values a given case has. And so we don't want mice using that variable trying to guess what people's responses were. And so I'm actually just going to delete the count NA variable from the data set. And I'm going to do that by saying deb2 equals subset left paren deb2 comma select equals and then minus. So the minus means actually deselect or delete. and I'm going to put C parentheses count NA close parenthesis, and that will delete the count NA variable from the data set. So now if I run names, you'll see it gives me the same names deb2. It gives me the same list of variables minus the count NA variable. Now I'm going to run a command from mice called md.pattern, P-A-T-T-E-R-N, for my data set. So md.pattern left paren deb2 right paren. And that will give me a graphic that shows me where the missing values are, and it kind of shows me if there are some people that have a lot of missing values. And so there's one person that has 4 missing values, and that's why the graphic shows 4 red boxes there. There are 2 people that have 3 missing values, and it shows those red boxes there, and those are kind of clustered together. Anyway, that can be helpful so that you can inspect and see if there's like, oh, there are a couple cases or there are a couple of values where there's a lot of missing data, and that could be problematic. Now, we're also going to do an inspection of the variables, and so we're going to do ini is the name of the output, equals mice left paren deb2, comma, max it equals 0 right paren. So that's just created a data frame or a matrix that that tells us how many missing cases are there for each variable. So if we do tabyl table ini $sign, I'm sorry, table left paren ini $sign nmis, that's number missing, nmis close paren, it'll tell us the number of missing cases for each variable. So we have 53 variables that don't have any missing values. We have 17 variables that have 1 missing value, 2 variables with 2 missing values, 1 variable with 3 missing values, 2 variables with 5 missing values, and 1 variable with 7 missing values. And that can just be useful to know. So you can, so for example, you can say, for this one variable where there are 7 missing responses, am I comfortable imputing it based on how many people I have? We have 339 people, and so I am comfortable, doing that imputation. Okay, now what are we going to do? We're going to create the imputed data frame, and so we're going to name that deb2 capital I. So deb2 capital I is just the name of the output, equals mice left paren deb2, so mice left paren deb2, comma, and deb2 is just the name of our data frame. Mice is the name of the command. And then meth is method, so meth equals, and then in quote marks, PMM. Now you can look at different methods for data imputation. What this does is it looks at the associations between all of the variables and then tries to guess a single value instead of an average value or an estimated value. So it's guessing a single value. So it assumes that what's being replaced is a factor, or in this case it's replacing, it's going to guess a specific number to replace the score. And then close the parentheses. And if you want to look around and experiment with different methods or want to understand why different methods are being used, you can check the supporting documentation for mice. I'm not going to get into that here. We're just going to use PMM as our replacement method. So we run that, and it's running, now it's estimating and replacing all of the values for all of the data sets. It takes a second. For all of the data sets, for all of the variables. We're allowing it to run. Okay. Now it says warning message, number of logged events 1. that's all well and good, we can inspect the logs of logged events. But if we run the summary deb2i, what it's telling us is that, it's telling us that the debate variable wasn't very helpful here, which is because it was just saying whether you were in debate 1 or debate 2. So it didn't love that, and that's why it gave us that. Then we can, anyway, you can learn what all of this means if you want to spend time looking at the supporting document for mice. This says number of multiple imputations 5. That's the number of times that it ran multiple imputations to guess what the output would be. It tells us the method for each of the variables, and it says PMM because we specified that. So it gives you a lot of information in the summary of the imputation process. I'm not going to get into that here because I'm not teaching you about missing variable imputation. I'm just teaching you how to do it. But we do need to take one more step. So we need to complete the imputation and create a compiled data frame. So to do that, we're going to say deb3 equals complete, C-O-M-P-L-E-T-E, left paren, and then deb2i, right paren. So we're taking the imputed data frame that we made, and we're compiling it into a single data frame or data set. So we run that, and now we can look at the MD pattern for deb3. So md.pattern, and then in parentheses deb3, and we get this cute little cat face that says no need for mice. This data set is completely observed. That's because we've imputed all the missing data. Now we can, let's see. We can run that same summary command that we did in the first video. So remember, deb is the original data set. And so if we get a summary for age, Joe Biden feeling thermometer, Donald Trump feeling thermometer, and control, for the original DEB data set, we'll see that there are 27 missing for age, 2 missing for Joe Biden feeling thermometer pre, 6 missing for Donald Trump feeling thermometer pre, and 255 missing in the control condition. And that just means there are 255 people that weren't in the control condition. But if we look at the summary for deb3 on those same variables, there are no NAs. So that last row NAs, there are none. There's no missing data. For age, that's because we imputed the median of 20 for everybody who was missing an age. For control, that's because we replaced all the NAs with zeros, indicating these people weren't in the control condition. And for these two feeling thermometer scores, it's because we used all of the information in the data set to guess what somebody would have replied had they provided a response. And you'll notice for the Joe Biden feeling thermometer, it didn't change the scores much. We only had 2 NAs, and the mean went from 44.57 to 44.57. So the mean didn't change at all. Neither did the median, right? So here, we didn't really change the mean or the median or any of the values in the summary of Joe Biden's feeling thermometer. All we did was keep the 2 cases of people who didn't give us that response. For the Donald Trump feeling thermometer, we get a median of 13 instead of a median of 14, and a mean of 31.91 instead of a mean of 32.33. So it does go down a little bit, and that probably indicates that the 6 people who didn't reply on Donald Trump's feeling thermometer were probably people who were statistically unlikely to like him very much based on their responses to everything else. My guess is that it's actually people who the feeling thermometer slider on the survey starts at 0, and my guess is it's people who saw it at the 0 and thought, yeah, that's good. And so they didn't think they needed to move it at all. And so they didn't have a score at all. So they probably would have given him a 0, and it probably guessed that they would have given him something pretty close to a 0. So that is how you use mice to impute missing data. The alternative to that is that you just delete people who didn't report a score, or you do something like mean imputation. And there's a lot of research in the missing data literature that shows that you get much more biased estimates if you delete random missing data, or if you do something like mean imputation. And you're much better off using one of the methods that a program like mice offers. So I hope you found that helpful. I hope that these videos help you in dealing with any missing data problems that you have. Yeah, let me know if there are other videos you'd like to see. I'm not always able to reply to comments. I'm not always able to make the videos that get requested. But I try, even if it's a little bit late. And I do eventually read all the comments. So thank you much.